Upon dusting off your old Nintendo, you discover that you have an old video game you forgot about, Super PID Brothers. How do you play it anyway? Well, the instructions are you have to help the Michigan Mario save the princess from the evil Ohio State Bowser. If you answer the questions correctly, you'll defeat Bowser's evil sidekicks and get to the next level. But if you answer incorrectly, you'll have a loss of life. Good luck! Interested, you decide to hit start. Level 1. Defeat the Goomba. Which type of controller, P, I, or D, is represented by the diagram on the right?
You think to yourself, wow, I don't remember Super Mario Brothers being like this. But with my knowledge of 466, I can definitely answer this question. It's obviously an integral controller because it takes time to reach steady state.
Yes, you got it correct and defeated the Goomba. The plot is for an integral controller. Now you've reached level 2. You have to defeat the evil piranha plant. Will a proportional derivative controller necessarily return a process to steady state? Yes or no? Please explain your answer.
The answer is no, due to offset. You need an integral controller to return to steady state.
That's right. You can't just use a PD controller. You'll still have the offset problems associated with proportional control. Now you've moved on to level 3. You have to defeat the Koopas. Which controller type exhibits a linear relationship between error and the controller output? What is the mathematical equation that relates these variables?
It's the proportional control. The control output is equal to the controller gain, Kc, times the error, E of t, plus the bias.
That's right. You still have some more enemies to face. This time it's a Spiny. If you want to limit overshoot, or control a process where inputs change rapidly, which type of control needs to be included in the scheme?
You need to include derivative control, because derivative control anticipates process conditions by analyzing changes in error.
That's correct. Derivative control relies on feed-forward control and is used in process where rapid changes are expected. Now you've reached the last level, and you have to face the evil OSU Bowser. Calculate the controller gain based on the following information. You have a proportional controller with a bias of 10 millivolts. Your error is 2 feet, and you get a controller output of 30 millivolts. You can use your calculator if you have to.
Well, based on the information and that it's a proportional controller, I know that the equation is C equals Kc times E plus B.
You're on the right track.
Plugging in the given variables, I think that the answer is 10 millivolts per foot.
That's correct. You defeated Bowser. And you rescued the princess. The princess says your incredible knowledge of PID control has allowed you to save me from the evil Bowser.